Hi, welcome to Chapter 8. Chapter 8, we're going to cover this thing called arrays. Looks like there's just 6 different sections. We'll talk about basic arrays and how to search an array, how to process the contents of an array, and talk about parallel arrays. That's two arrays that basically go together, two-dimensional arrays and arrays of 3 or more dimensions. So first thing we'll talk about is what is an array. An array is basically a variable. Now, it's a different kind of variable. I want you to think of this variable as a bookcase. So we declare the variable. It's a bookcase. But this bookcase, we can then add shelves to it, so that now this variable has multiple shelves that holds multiple pieces of data. So it's just one big variable that has multiple bookshelves. So the example they're using here is we declare an integer number and it's equal to 99. We set that number to equal to 5. So that variable holds basically one piece of data. I declare a string employee 1, string employee 2, string employee 3. So I've declared 3 variables. There's 3 separate variables. One's employee 1, employee 2, employee 3. We declare employee 50. So they're basically showing that if I needed multiple variables or objects, I would have to declare them separately. So here we have get the employee name, so enter the employee name of employee 1, input employee 1, display enter the name employee 2, input employee 2, display enter the name of employee 3, input employee 3. And then I display the enter the name employee 50, input employee 50. So I'd have to go from 1 through 50 in order to basically do this. And it would be very, very hard to do with a loop, since they're each individual separate variables. We have to declare each one of those variables separately as well. What we could do, though, is we could declare it as an array. So here I have declare integer units, and then it has a left square bracket, the number 10, right square bracket. So what that's basically saying is I'm declaring a variable called units, but it's a bookshelf, so it has 10 different shelves within it. And so now I can actually store 10 separate pieces of data. They're all the same exact item per se, but we can now declare it by shelf. We can utilize it and load it by shelf. So I have declare real sales amount, left square bracket 7, right square bracket. So whenever we see these square brackets with a numeric value in there, we know that that is an array. Here's declare string names 50. So now we have a bookshelf that has 50 shelves. They're all string and they're called names. Okay. The constant integer size equals 10, so that's an integer. It's a constant. Notice it's all caps, so that is a constant. And then I declare the integer units, and then I'm using the size constant as the number of bookshelves I'm going to have. So when I grab an element, so each one of those bookshelves is called an element. So when I'm grabbing an element from a particular array, I have to now give it what we call a subscript. And that subscript tells us which bookshelf we are dealing with now. So here I have my constant integer size equals 5. So there's my constant. I declare the integer numbers size. So size is 5. So there's 5 bookshelves. Now, whenever we deal with the bookshelves, we have to start with the number 0. So the very first bookshelf is always 0. And in this case, it's 5, so the last bookshelf or element is going to be the number 4. So 0, 1, 2, 3, 4. So if I want to assign an array element something, I would say set numbers, left square bracket 0, right square bracket 20. Numbers 1 is 30, numbers 2 is 40, so on and so forth. So we can see the example down here in the figure. The very first bookshelf, which is bookshelf 0, has a 20 on it. Bookshelf 1 has a 30, bookshelf 2 has a 40, bookshelf 3 has a 50, and bookshelf 4 has a 60. So this one whole big item is numbers, but each one is then a subscript or a bookshelf within that array. So here's a great example. So here we have constant integer size 3. So we've got a constant 3, and I'm going to declare integer hours and size. So that means I've declared a bookshelf called hours. The only thing that can go in this bookshelf are integer data. That's it. It has 3 bookshelves. Bookshelf 0, 1, and then 2. Display enter hours worked by employee 1, input hours 0. So we're going to grab whatever they type in and put that in the very first bookshelf. Enter the hours worked by employee 2, input the hours 1. So it goes to the next bookshelf. So 0, then 1. Then enter the hours worked by employee 3, input hours 2. So now we're basically grabbing the very last bookshelf. I display the hours you entered are, display hours 0, display hours 1, display hours 2. So we loaded the array and then we basically unloaded the array by displaying. So here, enter the hours worked by employee 1, we enter the number 40, enter the hours worked by employee 2, enter the number 20, enter the hours worked by employee 3, we enter a 15. And then the hours you entered are 40, 20, and 15. So again, here's our bookshelf. Bookshelf 0 has a 40, bookshelf 1 has a 20, bookshelf 2 has a 15. So using the loop to step through an array. So the great thing about arrays are we can now use looping to load them, unload them, and utilize the arrays through looping. So here I have declare integer series 10. So here I have a bookshelf. It's called series. It's an integer, which means the only thing that can go into this bookshelf is integer data. How many shelves are there? There's 10 shelves. I declare integer index. So I've now got a variable called index, and I say for index equals 0 to 9. So there's 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different shelving. I say set series index equals 100 and 4. So what I've done is each bookshelf, I put the number 100 into each bookshelf. That's all that did. So it basically went through. So instead of doing this 10 separate times, I did it once via a loop. So here I have a constant integer size 3. Here's declare integer hours size. So basically we're expanding on what we saw up above here. And then I declare integer index. So again, as we saw earlier, we basically did it, loaded each employee separately, employees 1, 2, and 3. So now I do an index is equals 0 to negative, to size negative 1. Oh, I'm sorry. For index, so the size is 3. So it says make 3 bookshelves. But now I want to go from 0 to size minus 1. Why? Because I can't go, because I've only got 3 bookshelves. It always starts with 0, 0, 1, and 2. If I said go from 0 to size, that would be 0, 1, 2, 3. That's 4 shelves. This array only has 3. We would get an error called index out of range, or out of bounds exception is another one we would get. So I say for index equals 0 to size minus 1. Which means if it's a 3, it's going to go from 0 to 2. Display enter the hours worked by, display employee number, index plus 1. So right now index is a 0. I wanted to say display the hour, enter the hours for employee 1. Well, I can't say employee 0, so this is for display purposes only is all we're doing here. It's going to say enter the hours for employee 1 because 0 plus 1 is 1. And then I input the hours index, which is 0 right now. So I input the hours for that very first bookshelf, and I enter that data into that array. I come back around. Index is now a 1. Display the hours worked by employee number, index plus 1. So 1 plus 1 is 2. First time it was 1. Now it's employee 2. And then input hours index So now it basically it gets the data from the user and puts that in bookshelf number 1. So bookshelf 0 has data, bookshelf 1 has data. Come back around, index is now a 2. Just enter the hours worked by employee number, index plus 1. So it was a 1. Now index was is a 1. Sorry, it's a 2. So we add 1 to it. It says now 3. So it's going to say, give me the hours for employee number 3. I then input the hours index, which is a 2. So 0 has a data in it, 1 has data in it, and now the third bookshelf, which is shelf number 2, now has data in it. Comes back around, that for loop basically says that's no longer true. It drops out, and now it says display the hours you entered are. Then we go through the same exact for loop. For index equals 0, 2, size minus 1, and it displays hours and then the index. Okay, so first time it's a 0, then 2, or 0, then 1, then 2, and then it basically drops out. So, and the hours worked by employee number 1. Again, the index was 0. We added 1 to it, so it displays employee 1. We enter 40. And into the hours worked by employee number 2, we put a 20 and put the hours into the hours worked by employee number 3. We type in 15, and it says the hours you entered are 40, 20, and 15. So again, they really kind of go through and talk about why do we do the -1 from our size, because whatever numeric value I use to declare the array with the number of shelves I need, number of elements, I cannot use that same number to do my I can't do the same thing for going through the loop, because it always has to start with 0. The very first element or bookshelf is always 0. And the last bookshelf will always be the number of shelves minus 1. So here's the spotlight. We'll go through this one. It says constant integer size equals 6. So I've got a constant, it's an integer, it's called size, we set it to 6. We declare real hours size, so now I've declared an array. So I got my bookshelf. It has how many shelves? It has 6 shelves. What kind of data can go into this bookcase? Only real data. No integers, no string, just real data. I declare real pay rate. So I have a variable called pay rate now. I have an array called hours, and now I have a variable called pay rate. I have declare real gross pay, declare integer index, for index equals 0, 2, size minus 1. We've already been through that. We know why we do the -1. Display, enter the hours worked by employee, index plus 1. We know why we do that. Input hours index. So again, we're just kind of going through the same exact program we just went through, except we're now expanding on it. And then I say display, enter the hourly pay rate, input pay rate. Okay, so this loop has now got all of the hours worked by the number of employees, which is 6. And now I display the hourly pay rate, because everybody's going to get paid the same. We're going to assume everybody gets paid the same. So now I go through and I say set gross pay equals hours index. So now we're reading each one of those bookshelves starting at 0. I multiply it times pay rate. Then I display employee index plus 1. So it's not going to say employee 0. It's going to say employee 1, employee 2, 3, so on and so forth. And currency format gross pay. Okay. Notice we got a $sign right there. And gross pay. So enter the hours worked by employee 1 is 10, 20, 15, 40, 20, 18, and then we enter the pay rate of 12.75. If you take 12.7 times, multiply it times 10 hours, the gross pay is 127.5. Employee 2, 20 times 12.75 is 255, and basically you can kind of go through and see. So each one of these, so 3 is 15 times 12.75, 4 is 40 times 12.75, 5 is 20 times, which is the same as number 2, and 6 is 18 times 12.75, which is 229.50. So how would that look like in a flow chart? Well, I got my start. I declare my integer size equals 6. I declare the real hours size. So I've declared my array, told it how many bookshelves are going to be in there. It's got 6. I declare real pay rate, real gross pay, and I declare integer index. I set my index equal to 0. And then I have my index, while the index is the index less than or equal to size minus 1. If that is true, we come in, display enters hours worked by, display employee index plus 1, input the hours index, set the index equals index plus 1. We come back around. If that's still true, we keep going through that loop. Once that is false, we drop out, we display the hourly pay rate, we input the pay rate, we set the index equal to 0 again, because we're going to reuse that index, and we come in and say, while the index is less than or equal to size minus 1, we're now going to come in, while that's true, we're going to set the gross pay equals hours index, and now we're reading that array. So we grab the very first bookshelf, the very first element, we multiply it times pay rate, we display employee index plus 1, currency format gross pay. Okay, notice we did not get the $sign in there, and we set the index equals index plus 1. We come back around, we keep doing that until the index is no longer less than or equal to size minus 1. Once that's false, we drop out. The program is over. Okay. Now, I can declare an array and initialize it at the same time. That means I can declare an array and load it with data in one step. And the way I would do that is here I have my constant integer size equals 5, and I declare integer numbers and left square bracket size, and then I set it equal to 10, 20, 30, 40, 50. So as you can see, I can actually go on the other side of the right square bracket, put an equal sign, and I have to make sure that the number of items, number of numeric data in this case, integer data, is the 5, which is the size. Okay? And I've got 1, 2, 3, 4, 5. I have 5 there. Here I have constant integer size equals 7. Declare string days size. So I've declared my integer, I've declared my array. It's an integer, it's a string. It's got 7 bookshelves. The first bookshelf's going to have a Sunday. Next one's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So I've declared an array called days, and I've loaded it with data in one step. Okay. So one of the things we really need to always be aware of is where we're at in our array. When we're reading our array, we're putting data into it, we're getting data out. We always got to make sure that we are within the range of 0 to the size minus 1. We can never go on either side of that. I can't go -1, I can't go 1 above that, or again I will get what's called an out-of-bounds exception. So here I've got constant integer size equals 5, declare integer numbers size, and then I go ahead and set number 5 equal 99. Then notice that's got a 5 in there. The size is 5. Do I have a number 5 bookshelf? No, I do not. I have a 0, 1, 2, 3, and 4. I do not have a number 5 bookshelf. So that would give me an error right there. Watch for one off by 1 errors. Now we kind of talked about that earlier when I want to display the employee number 1. Well, it's really employee 0 if I'm going by the index, but for display purposes we have to basically add 1 to it, so it says employee 1, employee 2, 3, 4, and 5. So the constant integer size is 100. So I've got my constant size, so I declare my integer numbers size, declare integer index, and I say for index equals 1, 2, size minus 1. Set numbers index equals 0. Okay. So the intent of the pseudocode is to create an array with the integers with 100 elements and store the 0 in each of those. However, this code has an off by 1 error, and the reason being is because it says for index equals 1 to size minus 1. What number do we always start with an array? We always start with 0. because that now said set numbers index equals 0. It set the number 1 bookshelf to a 0, then it goes 2, 3, all the way up through 99, but the number 0 bookshelf has a null value in it. It has no data in it at all. For index equals 0 to size, can't do that either. And the reason being is if I declare it with 5 bookshelves, I cannot grab number 5 bookshelf. It does not have a number 5 bookshelf. It has a number 0, 1, 2, 3, and 4. Partially filled arrays. So it says sometimes you need to store a series of items in an array, but you do not know the number of items in the series. As a result, you do not know the exact number of elements needed for the array. One solution is to make an array large enough to hold the largest possible of items. This can lead to another problem, however. If the actual number of items stored in the array is less than the number of elements, the array will be only partially filled. When you process a partially filled array, you must process only the elements that contain valid data items. So what they're saying is, if I have a partially filled array, I cannot try to grab data from an element that has nothing in it. I will get an error. So here I've got a size equals 100. I declare integer value size. So I have an array called values. It only contains integer data and it has 100 bookshelves, 0 through 99. Declare integer count equals 0. Declare integer number. So I have an integer called count. The variable integer count has 0 in it. Declare integer number. So I've got another variable called number. It has an integer, only contains integers. Display the number or -1 to quit. Input the number. While number not equal -1 and count is less than size, set value count equal number. Okay, so I set this array, that bookshelf number equals to whatever is in that numeric value. Okay, so then I say count equals count plus 1. So count started with 0, so the very first time in here, count is my index, okay? And then I add to it each time. So now I just enter a number, never one to quit. So in this case here, I can actually go through this array, and at some point when I type a -1 in, boom, I'm done loading the array. So that means I could have bits and pieces in there. Maybe I only have the first 10 elements in that array with data in it. That means 11 through 99 have nothing, okay? So now when I go through this guy, for index equals 0 to count -1, display the value index, well, that's going to work. That's going to work just fine because we know how many, we know the count. We know what the count was. But, and again, we're only dealing with the number of elements we entered data for. But again, we have a potential of having an error because if we try to grab data out of an element that has no value in it, we will get an error. We can use a for each loop. So we've seen a for loop. Now we have what's called a for each loop, and that's primarily utilized in an array. And so here I have for each var in array. Now how that works is the array contains, again, it's a bookshelf. It contains numerous elements. It knows how many elements it has. So this loop is going to go through how many times there are bookshelves. Okay? And what it does is each time it goes through this loop, it grabs the very first element and throws it into this variable called var. It does something, something, something. When it hits the end loop, it comes back around, it grabs the next, automatically grabs the next element and throws it into var. Goes through that loop when it comes back around, and it knows when to stop automatically, and it knows how to grab the next element for this process automatically. So here I have constant integer size equal 5. Declare integer number size equals 5, 10, 15, 20, and 25. So I've declared the variable, I've declared the array and loaded it at the same time as I've initialized it. I declare integer num. for each num and numbers. So what it does is here's my numbers. It grabs the very first element, throws it into num. I display num, so displays 5. When it hits this end, it comes back up and says, are there more elements? If there is, grab me the next element and throw it into num. Display num, it displays 10. Hits this for loop, comes back up, says, is there another element? If there is, throw it into num, and it does. It grabs 15. Now it displays 15. So it's going to keep doing that, going through that loop, grabbing each element, throwing it into num. It displays the num until it basically runs out. When it comes back up and says we have no more, it basically stops and basically drops out of the loop. Okay, so the next section talks about how to sequentially search an array. Now, sequentially means we start the very first element and we basically go boom, 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 boom until we find what we are looking for. So in this case, here is my set found equal false, set index equals 0. While found is equal false and index is less than or equal to size minus 1. When those two are true, it comes over here and it says array so the array at that bookshelf number, the index, if it's equal to that search value, if that's true, we set found equals true. Else we set index equals index plus 1 and we come back around, and so we're either going to drop out of this this loop by either we found something or we basically went through all the elements. Okay, so here I've got set found equals false, set index equals 0, while found equal false and index is less than or equal to size minus 1, while those are both true, we come in here and say if array index, so the array at that index, that bookshelf, while it's equal to the search value, then so if that is true, we set found equals true. If it's not, we set the index equals index plus 1. We come back around, hit that while loop, and we keep doing that until we basically either find something, set that to true, or we've gone through all of the elements and we are done. So here we have a constant integer size equals 10. So I've got a constant. It's called size. I declare my integer scores by size, which is 10, and I'm going to go ahead and load it with 87, 75, 98, 100, 82, 72, 90, 99, 92, 60, and 78. I declare a Boolean found. Declare integer index. I set found equal false. I would have probably done that right there. I would have said declare Boolean found equal false. But anyways, so I set my index equal to 0. While found equal false and index is less than or equal to size minus 1, which is 9. So while this index is less than 9, or less than or equal to 9. If scores index equals 100, then set found equals true. So first time through it's 87. So that basically is false. We set the index equal to index plus 1, so it's now set to 1. We come back around. Is score index, which is now 75, is that equal to 100? No, it's not. We set index equal to index plus 1, so it's now a 2. Okay. We come back around. If score index, which is 2, so 0, 1, 2, which is 98, is that equal to 100? No, it's not. So we set index equal to index plus 1, which is now 3. We come back around and we say if score index, which is 0, 1, 2, 3, that is 100. Is 100 equal to 100? Yes, it is. Set found equal true. We come down here, we come up, while found equal false, it's now true, so we drop out of that loop. And we say if found, which found is true, then display you earned 100 on test number and index plus 1. Okay, so again, whatever the index currently was, which was 0, 1, 2, 3, but that's actually the 4th score, I want to display the number 4, not the number 3. Else display you did not earn 100 on any tests. We can search a string array the same exact way. I've got my constant integer size equals 6. I declare string names size and I load it with Ava Fisher, Chris Rich, Gordon Pike, Matt Hoyle, Rose Harrison, and Giovanni Ricci. So I've got what, six? I've got 6 names in there. Declare string search value. Declare Boolean found. Declare integer index. Set found equal false. Okay, so found has false in it now, but index has a 0. We set that to 0. And display enter names to search for within the string. Input search value. So I'm letting the user now input a search value. While found equal false and index less than or equal to size minus 1. If the name index is equal to the search value, whatever you typed in, we're going to set that to false. Set found equal true. Else we're going to go ahead and increase the index by 1 each time. So we kind of gone through that. We know what's going to happen. So if we find the name that we typed in, it will set that to true, and it will come back and say the name I found, if found, display the name was found at subscript and then whatever index number that was. Else display that name was not found in the array. So here we've got often programs must be designed to search for particular string matches. Most languages provide library function that can determine whether the string partially matches. So I'm now looking for a partial match. So I can use what's called a contains function. Okay, so contains functions accept 2 strings as arguments and returns true. Okay, so here we have our constant integer size equals 6. We've got our array with those 6 names we just saw a second ago. Declare string search value, declare Boolean found, declare integer index, set found equals false, set index equals 0. So I kind of get everything initialized, no difference yet. Then I say display, enter the name to search for an array, I input that search value. So at this point nothing's different. In my while loop now though, I'm saying while found equal false and index is less than or equal to size equals 1, no difference there. But now in my if statement I say if contains names index search value, then set found equal true. So what we're doing down here is we typed in the name Matt and it did find Matt Hoyle. But it could essentially find more than one Matt. But in this case, once we find it, we drop out of the loop, so we wouldn't find any more. We would find the very first instance of Matt. So contains, I could say, so if we typed in the name Matt, and I said if this particular array contains the name Matt, we're going to call that a found, and basically set found equals true, and drop out of the loop. So really nice function, contains. So here we're going to process the contents of an array. So we want to total all the values in the array itself. So here I've got set total equals 0, set the index equal to 0. Then say if the index is less than or equal to size minus 1, if that's true, I set total equals total plus the array index. So again, I'm assuming that this array has numeric data. I'm adding that to the total variable. I set the index equal to index plus 1. I come back around, do a check. Have we basically gone beyond the size of this array? If not, we're going to keep going through and grabbing each element and adding it to total. This is what it looked like in pseudocode. So I've got declare integer numbers size, which is 5. That's got 2, 4, 6, 8, 10. Declare integer total equals 0. Because again, if we're going to add something to total, we got to initialize it first. Declare my integer index. For index equals 0 to size minus 1. I set total equals total plus numbers index. So very first index is a 0, which is 2. I add that to total. So since total has a 0, it basically adds 2 to 0, which is now 2. We come back around and grab the next element, which is 4. We add that to 2, which is now 8. And then 6 added to 8 is 14. 8 added to 14 is 24. 10 added to 24 is 34. No. Am I right? So 2 and 4, no, 2 and 4 is 6, sorry. 2 and 4 is 6. 6 and 6 is 12. 12 and 8 is 20, and then 10 is 30. Yep, correct. Okay. Sorry, I had to go through basic math. Averaging the values in an array. So now I want to grab all of the numbers, total them, So we've seen that. So here I've got 2.5, 8.3, 6.5, 4.0, and 5.2. So I'm going to go through and I want to total all of those items up. Now I know the size of my array is 5 because I've set that to my constant size. So here I've gone through my loop, which totals. So now total, when I get through that loop, total has taken all of those numbers in that array and totaled them together in one grand total. But now I can take the total, divide by size, which is 5, and that one I can put that into this average variable. And then I can display the average of the array element as average, which is going to be 5.3. Okay? So that's great. I can total my array. I know how many elements are in that array. I divide by the number of elements. I now show the average of those numbers in the array. Finding the highest value in the array. Okay, so here I've got my size equals 5. Here I've got my integer numbers size, so I've got a variable called numbers, only contains integer data, and it has 8, 1, 12, 6, and 2. I declare my integer index, I declare my integer highest, I set the highest equals to numbers 0. So I grab the very first element of that array and I throw it into my variable highest. Now notice what I'm going to do with my for loop. I'm going to start my for loop at number 1. Why? Because I've already grabbed the very first element and throw it into highest. So now I go 1, 2, size minus 1. So now when I say numbers index 1, which is actually the number 1, is that greater than highest? So is 1 greater than 8? No, it's not. So I come back around. I've increased index by 1. I'm now at index number 2. Is 12 greater than 8? Yes, that statement is true. So now I say set highest equals to numbers index. So it grabs the number 12 and throws that into highest. We come back around, we grab the next element. Is 6 greater than 12? No, it's not. We come back around and check. We say is 2 greater than 12? No, it's not. So now when I come down here, I say display the highest number in the array is highest, which is 12. And this is what it would look like in a flow chart. Set highest equals array 0, 1, or the very first element, which happens to be 8, and I set my index equal to 1. And while the index is less than or equal to size minus 1, I grab the next element, which is the number 1 element in this case, and I see if that's greater than highest. If it's not, I set the index equal to index plus 1, and I come back around and I keep doing that. If it is true, I go ahead and set highest equal to that particular number. I don't want to go through this whole lowest because it's identical to the highest, except instead of doing is the array index greater than to highest, I'm saying is the array index less than lowest. So basically that will do the same exact thing. If I need to copy an array, I want to make an exact duplicate of an array, I can say constant integer size equals 5. I declare my integer first array size equals 100, 200, 300, 400, 500. I declare integer second array size. Now I cannot just make second array equal to the first array. It doesn't work that way. What I have to do is I have to go through the first array one element at a time and load it into the second array. So for index equals 0 to size minus 1, set the second array at that index equal to the first array at that index. And it basically takes each bookshelf out of number 1 and sticks it into number 2. Grabs the next bookshelf, throws it into number 2. Okay, it keeps doing that. Pass an array as an argument to a module or function. Okay, so this is getting into what we've covered in previous chapters. So here I've got a constant integer size equals 5. Then I have declare integers number size, which is 5. And here I've got my 2, 4, 6, 8, 10. I declare integer sum. Set sum equals get total numbers size. So now here I have a function that is called function integer, that means it's returning an integer data type. It's called getTotal, and here I've got my integer array. Now notice it's got array and it's got a left and right blank square bracket. That means it's telling the getTotal that you are receiving an array. I don't know how many elements are in there, but you will have an array with a certain number of elements in it. And then I have an integer called array size. Okay, so there I declare my integer index. I declare integer total equals 0, and then I say for index equals 0 to array size minus 1. So I've told it how many elements are in the array by this array size. I set total equals total plus array index. So whatever is in this array, I'm going to grab each element one at a time and add it to total. Then at the very end, I return total. So what I've done is I've passed the array to my function. It goes through each element one at a time, adds it to the total, and then it returns the total. So up here, when I say set sum equals get total, it went through and grabbed each element and added them together, return total, and it throws total into sum. So now sum has the total of that array. Display the sum of the array is the sum of the array elements is sum. So it's pretty cool. So instead of us going through all of this, so the great thing about this function is it can be used anywhere, because we just pass an integer array to it and the size of that array, and it's going to go ahead and go through that array and add up all of the elements and then return the total of those elements. So it returns an integer. Yeah. So here we have Dr. LeClaire gives 4 exams during the semester in her chemistry class. At the end of the semester, she drops each student's lowest grade score before averaging the scores. She has asked you to design a program that will read the students' 4 test scores as input, calculate the average with the lowest score dropped. Okay, so here's the algorithm we're going to do. We're going to read each student's 4 test scores. We're going to calculate the total of those scores. We're going to find the lowest score, subtract the lowest score from the total, and that will give us the adjusted total. We're going to divide the adjusted total by 3, which is the average, and we're going to display the average. So here we have our module main. We've got our constant integer size equals 4, because that's how many elements we're going to have in each array. We declare a real test score size. Okay, so we've got test score size. We've just declared an array called test scores, and it's got 4 bookshelves in it. I declare real total. I declare real lowest score. I declare real average. So now I've got 3 variables: total, lowest score, and average. I call get test scores, and I'm passing the array test scores and the size. So if I come down here, where is it? Get test scores. Where's that function at? Okay, apparently not going to show us. So I've got call get test scores, so I pass the test score array to that function. What that function is going to do then is ask the user for each test score to basically load into that array. So it's going to load 4 test scores into that array. So when we get back, I'm going to say set total equals get total of test scores size. So now I've got the total of all of those elements of that array that we basically loaded in the get scores function. So the get total does just that, gets a total of those. Then I say set lowest equals get lowest. So now I call get lowest, I pass in the array, and what it's going to do is it's going to then go through and find the lowest score and return that score to us. Then we are going to set the total equals total minus the lowest score. So now I've taken the total that I've got of all 4 scores, I subtract the lowest score, so now I have a new total, and then I divide that new total by size minus 1, which in this case is 3. Okay, so I'm sorry, it was 4. It was 4 because we had 4 test scores. I want to divide by 3, and I get the average for those 3 test scores. And I say the average the average with the lowest score dropped is the average. Okay, I'm sorry. The average with the lowest score dropped is, and then we display that new average. Okay. So what they're not showing us here is they're not showing us the get test scores, the get total, the get lowest. We're going to assume that we already know how to basically do those things. And again, this is what it would look like in a flow chart. Constant integer size equals 4. Declare the real test score size. Declare real total. Declare real lowest. Declare real average. We get the test score, so we're calling a function. We're going to pass in the array and the size. We get total equals get total test scores and size. Okay, so we're calling another function to get the total, and we're setting that to our total. Get the lowest, so set the lowest by calling a get lowest function, and then we basically set the total equals total minus lowest score. We set the average equals total minus size minus 1 because we only want to divide by 3 instead of 4. Display the average with the lowest score. What the lowest score dropped is average, and basically we are done. So here's the get test scores. So module get test scores, real ref scores, so we're basically passing by reference. So again, we're not passing anything back because we are passing the array, and whatever gets changed will automatically get changed because we are basically dealing with the same exact array because we're passing by reference. Okay. And again, here's the calculation program. Here is the get lowest, and then here's the flow chart for each one of those. You can kind of look at those at your leisure. Okay, so the next section gets in this thing called parallel arrays. So the thing about arrays are we can only load one data type. So when I declare my bookcase, at this big bookcase, guess what? I can only, if I declare it as integer, that's all I can put in there. But let's say I have students names and I have students test scores. Well, I can't put the students names in the test scores array because it's not going to work. So what I can do instead is create 2 arrays that are parallel. That means element 0 in this goes with element 0 in this array. So here I've got Tommy Smith and his test score. They're both 0. Number 1 go together. The number 1 elements go together. Number 2 elements go together, and so on and so forth. That's what we call a parallel array. Example we see down here, we have a constant integer size equals 6. We declare our string names size. So we said we just declared a bookcase. It has 6 shelves, and it can only contain string data. Here I have another array called addresses. It's got 6 shelves, and it can only handle string as well. So I come down here, and so what we're saying is names has just names in it, addresses has just addresses. And element 0 of this goes with 0 of this. So person 1 is these 2 elements, person 2 are these 2 elements, so on and so forth. So it allows us to basically use 2 arrays to get data that we can't combine. So here we have Megan asked you to design a program that allows her to enter her numbers of hours worked by each of her employees and display each of the employees' gross pay as is currently designed. The program refers to the employee as employee 1, employee 2, and so on. Megan's asked you to modify the program so she can enter the employees' names along with their hours, and it should display each employee's name along with his or her gross pay. Currently, the program has an array called hours and holds each employee's hours worked. You decide to add a parallel named names that will hold each employee's name. The first employee's data will appear as name 0 and the hours 0. Okay, so the names array 0 and the hours array 0 is for the same exact person. So here we have constant integer size equals 6, so the array holds 6. We declare the string names as size. We declare real hours size. So here we've got real data. The name of this array is called hours. It's going to have 6 elements. The only data that can go in there is real. Here we've got our names array. It's got 6 shelves. It can only hold string data. We declare real pay rate and real gross pay. We declare integer index. So we've kind of seen this before. The only thing we've added now is the names array. So I go for index equals 0 to size minus 1. Display enter the name of the employee index plus 1. So it says enter the name of employee 1, not employee 0. Input names index. Display enter the hours worked by that employee. Input hours index. So I'm getting 2 inputs. One's for the name, one's for the hours. I'm putting those in each of those elements. So element 0 for names and element 0 for hours. When I get through with that loop, I now have my 2 arrays filled with data. Name and the hours worked by that employee. I get the input pay rate. They all make the same pay rate. Display here is the employee's gross pay. For index equals 0 to size minus 1. Set gross pay equals hours index times pay rate. Display names index colon currency format gross pay. So here I am basically displaying the gross pay for each one of those employees. So here I've got Jamie Lynn, she worked 10, Courtney worked 20, Ashley worked 15, Brian worked 40, Jane worked 20, Ian worked 18. The pay rate is 12.75, and here's the employee's gross pay. Jamie Lynn, 127.5. So again, 10 times 12.75 is that. Now the one thing I did notice, they said display names index colon space. There is no dollar sign, but down here they have dollar signs. Arr! So basically the one thing they didn't do is put a dollar sign in there. Here's basically what the flow chart would look like. Again, we declare all of our variables and our constants and our arrays. We set the index equal to 0 while the index is less than size minus 1. We go through all of this and we then display, and then we basically go through that same loop to display the gross pay for each of the employees. So parallel arrays. Now I could have had a third array, and that array could have been pay rate. So I could have had 3 arrays. First array is the name, the next array is the hours, and the next array is the pay rate for each of the employees. And then I could, again, the element 0 of all 3 of those arrays goes for one person. Element 1 for each of those 3 arrays is for the second person, and so on and so forth. So parallel arrays are not just 2 arrays, it could be more than 2. And the reason we would do that is because the names are strings, hours are integers, and pay rate is real data. So 2-dimensional arrays. Now when we talk about 2-dimensional arrays, I want you to think of a spreadsheet where I have columns and rows. And so what we would do is I would declare integer values 3 in a square bracket and 4 square bracket. And what that means is I'm going to have 3 rows and 4 columns. Okay? So now I have a constant integer rows equals 3, constant integer columns equals 4, and then I say declare integer values rows cols. So basically we'll do the same exact thing. So now if I want to grab the data, let's say for this particular element, I have to grab column 1 and row 2. Okay? So if I want to go across this first row, I would say value is 0, 0, 0, 1, 0, 2, 0, 3. Second row would be 0, 1, or values 1, 0, 1, 1, 1, 2, 1, 3. Next row is 2, 0, 2, 1, 2, 2, and 2, 3. And that's basically what we see right here. So here I have constant integer rows equals 3, constant integer cols equals 4, declare integer values rows and cols. So declare integer row call. So I got an integer called row, integer called call. Okay. Notice they don't have an S on the end, so they're singular and they're not uppercase, so they're not part of that constant. For row equals 0 to rows minus 1. For call equals 0 to cols minus 1. So now here I've got a loop inside of a loop. We've seen that before when we talked about the hours, minutes, and seconds. So we're going to do all the columns. So this first time through, it says input values row call. So this first time through, row is 0, call is 1, then call is 2, or call is 0, then call is 1, then call is 2, and we drop out. Then we basically increase row by 1. We come back into this loop again, and now we go 1, 0, 1, 1, 1, 2. We come back up. We set the rows to now equal to 2. We come in here, so now it's 2, 0, 2, 1, 2, 2. So once I've entered all of those, then I can go through and loop through it again to display what I've entered. Okay, so here it says enter a number 1, 2, 3, 4, 5, 6. Here's the values you entered is 1, 2, 3, 4, 5, 6. So I've gone through this 1, 2, 3, 1, 2, 3, 1, 2, or how many is there? Oh, 3 and 4, right. I could do this. I could declare a two-dimensional array by basically saying test scores equals 3 and 4, which is basically 12, right? So it'd go three rows, 4 columns. So 1, 2, 3, 4 would go in the first row, and this would automatically go in the second row. 67s, boom, 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 and then this third row would basically be those. So it basically load it. Starting here, it would go 1, 2, 3, 4, boom, 1, 2, 3, 4, boom, 1, 2, 3, 4. It just grabs each one of those and loads them in there. Okay, so please go through this two-dimensional array in the Spotlight on your own to kind of get a better feel of how to do two-dimensional arrays. Okay, I don't want to spend a whole lot of time on this, but just more or less let's talk about it conceptually, because this really gets super complex. So if we have more than two-dimensional arrays, can we have 3, 4, 5, 6-dimensional arrays? We most certainly can, but just think of that as really super complex. Okay. So think of this as here's row 0, row 1, row 2, here's each of the columns, and then we've got boom, boom, boom. So here's page 0, page 1, page 2. So I would go 0, 0, 1, so that means we're on page 0, row 1, column 1. I would go 0, 0, 1, which means page 0, row 0, column 1. What if I had 2, 0, 0? Well, that would be page 2, row 0, column 0. Yeah, I don't dwell on that too long, but just realize it is possible to do that. Okay, I believe that is it for this particular chapter. Again, go through the spotlights. Really get a good feel for how to do an array. Okay. Again, realize an array is a bookcase, and we have to declare how many bookshelves, and they all hold the same data. And when I refer to each, when I declare the variable, I'm talking about the entire bookcase. Then I have to put the number behind it to get to that particular bookcase or that element with that index to get that particular data, to either load data into it or get data out. Again, if you have any questions, give me a call, contact me, email, whatever, and I'll be glad to Skype with you and help you with any issues you're having.